This question comes from Owen, who asked, "Could you build a bridge across the whole Pacific Ocean so you never have to fly again?" I won't spoil the answer, but by the end we'll need to measure things in units of how many Mount Everests, if that tells you anything about how badly this goes. Let's start with the easy part. How far is it? The Pacific is about 12,000 kilometers across at its widest. That's roughly 3 trips from New York to Los Angeles laid end to end. Not fun, but not the real problem either. The real problem is underneath the water. The average depth of the Pacific is about 4 kilometers. Some trenches go down 10 or 11 kilometers. Deeper than Everest is tall, just flipped upside down and filled with water. The tallest bridge supports we've ever built go maybe half a kilometer into open water. To plant a support in the middle of the Pacific, you'd need something roughly 8 times taller than anything humanity has ever anchored to a seafloor, and you'd need thousands of them. So, obviously, we don't put the bridge on the bottom. We float it instead. Floating bridges already exist. There's one in Washington State a couple of kilometers long. Owen, if you wanted the Pacific version, you'd need one about 6,000 times longer than that. It's less build a floating bridge, and more build a floating bridge the length of everything humans have ever floated, several thousand times over. And floating brings its own problem: storms. The Pacific isn't a lake. It generates typhoons with waves over 30 meters tall. Any floating structure would need to flex with waves that size across its entire length, all day, every day for decades, without a single weak point failing catastrophically. Here's where the escalation really kicks in. Say we give up on one continuous span and build floating islands instead. Giant platforms every few kilometers, connected by shorter bridge segments. Better. Except now each island is basically its own offshore city, anchored in open ocean, and you need roughly 2,000 of them. Let's be generous and say we actually pull that off. Now you've got a chain of 2,000 artificial islands stretching across the Pacific. Ships still need to get through, so you'd need drawbridge sections on nearly everyone. Otherwise, you've just built a 12,000-kilometer wall that quietly strangles global shipping. And even if you solve the ships, you still haven't solved the money. The most expensive bridge ever built cost a few $billions for a few kilometers. Scale that up 6,000 times, and you're somewhere in the tens of trillions of dollars. More than the entire world spends on infrastructure in a decade, spent on one crossing. So here's the honest answer, Owen. The ocean depth is a problem you can float your way around. The storms are a problem you can engineer your way around, expensively. But the sheer scale, thousands of kilometers of the most storm-battered water on the planet, needing thousands of independent structures that all have to survive decades without a single catastrophic failure, is the thing that actually breaks. Not the physics, the bookkeeping. P.S. If you're wondering whether a tunnel would be easier than a bridge, it's worse. You'd be drilling through rock that's colder, higher pressure, and far less forgiving than open water, for the exact same 12,000 kilometers. At least the bridge lets you see the ocean while it slowly bankrupts you.